For topic 2, we need to introduce the idea of a function. Okay, again, when you get to your pre-calculus class, you are going to talk a lot about functions. Okay, so we're just kind of building a really basic foundation so that when you get to your pre-calculus class, you'll kind of understand what's going on, generally speaking, and then you can expand that information as needed. So the definition, a relation in which each member of the domain corresponds to exactly one member of the range is called a function. Okay, so that's really important that you understand this. We already know from the previous video that a relation is a situation where elements in one set are associated with elements in another set. For us in math, that's typically ordered pairs. Okay, now for a set of ordered pairs to meet the qualifications to be a function, each element in the domain can correspond to only one element in the range. What this means is that x's cannot repeat. Okay, so this means x's cannot repeat. And we'll bring this back up again in just a second. Okay, so in order for each x to correspond to only one y, that means x values can't show up more than once, because if a single x value shows up more than once, that would indicate that it corresponds to two different y values. Okay, so no two ordered pairs of the function can have the same first component and different second components. That means if you're dealing with a function, for us again, that's going to be ordered pairs. That means the first component x, you can't have a situation where you have the same x corresponding to two different y's. Okay, that's not a function. It's certainly a relation, which is fine. It just doesn't meet the criteria to be a function. So essentially, what you need to remember, x coordinates cannot repeat. Okay, you can have a set of ordered pairs, and as long as each x value shows up only once, you're golden. Okay, so example 2 here says determine whether each relation is a function, state the domain and the range. Okay, so we don't have a ton of room, especially for part A. We're going to do the best we can. So first of all, we have to determine if we have a function. So that means x values cannot repeat. And in part A, we have what's called a mapping. So the elements in the first bubble correspond to the elements in the second bubble. That means the first bubble is the input values. So generally we think of this, not generally, but we think of this as x. And then the second bubble is the output values. We think of that as y. Now notice the arrows. So here we can see that Indiana corresponds to Dan Coates. Washington corresponds to Maria Cantwell. North Carolina corresponds to Richard Burr. Oregon corresponds to Ron Wyden and Jeff Merkley. That's a problem. Okay, this is a beautiful relation, but this right here is not a function. And then finally, we have that Maine corresponds to Susan Collins. So if we were to think of this as a set of ordered pairs, we have I for Indiana, DC for Dan Coates. Washington, we have W, and then MC for that senator. North Carolina, we'll call it NC, RB for the senator. Oregon, we have two different senators listed here, okay? So Oregon corresponds to Ron Wyden, and Oregon corresponds to Jeff Merkley. And then finally, Maine corresponds to Susan Collins. This right here, the x coordinate repeats. So this is not a function. Okay, and it's not a function because Oregon, that one input value has two output values. So we have one x coordinate that corresponds to two y coordinates. Can't happen. It's a lovely relation. There's nothing wrong with it as far as a relation is concerned, but it's just not a function. Okay, now if we needed the domain and the range, let me erase this right here just for the sake of space. I didn't give enough space for this problem, so apologies I don't want to say in advance, but apologies now. So the domain would be all of the states. So we have Indiana, Washington, North Carolina, Oregon, and Maine. And the range would be the senators. We have Dan Coates, Maria Cantwell, Richard Burr, Ron Wyden, Jeff Merkley, and Susan Collins. So that would be the domain and the range. Okay, let's look at part B. For part B, we just have a set of ordered pairs, which is fine. So we need to look at the domain and the range. So let's look at the domain and range first, then we'll determine if it's a function. So in the domain, we have values of -2, -1, 0, 1, and 2. For the range, we have values of 6, 3, 2, 3, and 6. So is this a function? Now, in order for this to be a function, each input value can correspond to only one output value. So we're really focused on those x's. Do the x's ever show up twice? If so, that would indicate a single input value corresponding to two output values. Well, if I look at my x's, they're all unique. So x's don't repeat. Which is a good thing. That means this is a function. And we have our domain and range listed already. Now, when it comes to the range, don't worry about the range repeating. That's fine. You can have multiple x values correspond to the same y value. You just can't have one x value correspond to multiple y values. Otherwise, it's a relation, but it is not a function. So remember, the criteria to be a function is each input corresponds to only one output, meaning x's cannot repeat. Y's can repeat, that's fine. X's cannot. Okay?